This will be for the Khan Academy exercise, classify discontinuities. All right, so there's three main types of discontinuities. So in the removable discontinuity, the point is literally removed, okay? You can see right there, there's a hole in the graph. It does not matter if the point is replaced or not. The idea is just that there is a point that is removed, but the two-sided limit still exists. And you can see on the graph right here, here's x equals a. If you approach a from the left or if you approach a from the right, it still approaches the same point from either side. So that's why I said that it's basically a two-sided limit. But the way I remember removable is that there's a point that's removed from the graph, but the line or the graph just continues as it were. Now for the jump discontinuity, the graph almost literally jumps, but it continues, okay? So you'll have part of the graph on one side, and then there's a jump, and then there's part of the graph on the other side. That graph will have only one-sided limits when there's a jump. So if you see x equals a, if you approach a from the left, give me one sec here. All right, so just to clarify it a little better, there will be one-sided limits, but they're going to be different. Okay, so here's the jump discontinuity at x equals a. When you approach from the left, it approaches this point here on the y-axis. But if you approach it from the right, it approaches that point right there. All right. So for the removable, the point is just removed, but the two-sided limit is still the same. But for the jump discontinuity, the graph literally jumps and continues on, in which case there's going to be one-sided limits, but they're going to be different. When you approach from the left, when you approach from the right, you can see that y coordinate is different for each one. And the easiest one is the infinite discontinuity. You're going to have vertical asymptotes, and it will continue to positive or negative infinity. But infinite is the easiest. Jump, the graph literally jumps, and you have different one-sided limits. Removable, there's a point that's removed. Whether or not it's replaced is irrelevant, but there's going to be a two-sided limit. So those are the three discontinuities we're going to deal with today. All right, it says select the x values at which f has infinite discontinuity. So before I even look at the multiple choices, it's going to be choose all answers that apply. Infinite discontinuity, we already said it. It has to have vertical asymptotes. All right, it's going to have vertical asymptotes. So let's just find those. Well, these right here, the left-right ones are horizontal. That's irrelevant. But right here, we have our vertical asymptote. Okay, one of them goes to infinity. The other one goes to negative infinity. And where does that occur? Right here at x equals -5. There is nowhere else on the graph where there's a vertical asymptote. So the only possible answer is going to be x equals -5. And no, I'm sorry, I did not mean -5. There's a dash there, so I thought it was negative. This is +5. Correction, +5. So only answer C. All right, so here we have the function g. Where's the x values where g has jump discontinuity? All right, I don't think it occurs anywhere here, okay? Because this right here is removable, okay? The point is removed, but there's still a two-sided limit. It still approaches the same point from both sides. So this right here is removable, and if you keep going, this right here is the infinite because there's an asymptote. Here is the infinite, there's an asymptote, and if you keep going, there is no more discontinuities. Okay, so this is removable, this is infinite, There is no jump discontinuity on this graph. So this one is going to be none of the above. All right, here we are looking for removable discontinuity. So removable, the graph should just be a point that's removed, but it should continue. Okay, right here, there's a hole in the graph. It's undefined. That's a discontinuity right there. Does the graph jump? No, it's just a point that is removed, but then the graph keeps going. If you look at the two-sided limit, if you approach from the left or approach from the right, it approaches the same y coordinate. This is a removable. So this point right here is at -6. Okay, so that's one of them. And like we said, in case you didn't catch that, the point for removable, that just means it's removed. Okay, that just means the point is removed. So that's what it is right there. The graph continues, and there's still a two-sided limit right there. So that's good. At -6, that's removed. Okay, let's check out the next one. Right here at -3, the graph literally jumps. All right, it's coming from the left. It jumps up to here, and then it's going to the right. If you had a one-sided limit, right here it approaches +2. That's from the left. Right here from the right, it approaches +5. So that's two different one-sided limits. This right here is a jump. Okay, the graph literally jumps and it continues on, but it has different one-sided limits. This one has a two-sided limit. That's the same. So we're looking for removable. -3 is no good. The rest of the graph does not have any discontinuity. So -6 is the only point for the removable. All right, so here we're looking for infinite. That's the easiest one. Let's see. We need vertical asymptotes for infinite. Right here we have it. Okay, and you can see on both sides, the graph is just going to negative infinity. So right here at -6, that's good for infinite. It doesn't matter if both go down or one goes up and one goes down. It doesn't matter. Right here at the vertical asymptote at -2, we can see this goes to negative infinity. This goes to positive. So yeah, -2 is good as well. And the next discontinuity traveling to the right is right here. This point is basically removed. Okay, so that one right there is going to be a removable. And how do I know that? Because not only is the point removed, but the two-sided limit exists. If you approach from the left, if you approach from the right, it's going to approach the same y coordinate. So that's not a jump, that's removed. It doesn't matter if this point is here or not. It doesn't even matter. The idea is that there's a point that is removed and the graph just keeps going the same way as it would have on either side. So this would have been a removable, but they asked us for infinite. So it's just -6 and -2. All right, one more for fun. We're looking for the jump discontinuity. So let's see. Starting from the left, here's the first discontinuity. The point is removed right there, but it continues as it were. Okay, it still has a two-sided limit. So that one right there is removed. We're looking for the jump. Right here, there's a jump. You see the graph goes here, and then it jumps and continues. We have two one-sided limits. The graph literally comes from the left, jumps, and then keeps going. So that is at x equals 1. And also up here, goes to the left, and then it jumps down here, and then it keeps going. So that one is at x equals 2. All right, so we have two actual jumps. There's two different one-sided limits at 1. There's two different one-sided limits at 2. So it's just 1 and 2.